Traditional prosthetics and medical grade devices, there's a lot of challenges for children. Some of these are cost. A bionic arm that's functional can cost upwards of $40,000, all the way to $100,000. And children grow all the time. You see how fast children grow through their sneakers or their shoes, right? It's always going to be a challenge. And traditional companies and the current medical society says, you can't keep replacing these expensive devices while children are growing, just wait till they're 18. And so we tell children, you're perfectly made, you can adapt, but they just needed better tools. It wasn't the children that ever needed to change. And so we had these great challenges, and we said, how do we do this? And engineers, we love to solve problems, right? And I think it's just in our wiring to do that. And so we made Alex his first arm, and then he went to school, and it changed everything. This first real Iron Man arm went from a movie set, right? Into a classroom and onto a playground. And that's where it is every day right now. And it goes to school with Alex every day. And what we found was this was so incredible, not just in terms of his functionality as he was learning how to do two-handed tasks, or when one arm was full carrying something, he would instinctively reach with his bionic arm. And that happened little by little. But it built his confidence. And out of nowhere, the same child who was afraid to go to the grocery store because of how people would treat him, or was being bullied in the classroom, is now filled with confidence, and it ignited his imagination to really dream. And now he and his classmates are all telling us how they want to go to university so that they can use engineering and science to help their communities. So where's this going? We're research scientists, we're students, graduate students, and we want to make things better. We're hoping we can combine traditional manufacturing, additive manufacturing, biomechanical engineering, and bring it together to do something that's never been done before. Looking at printing with titanium, making artificial bones, new types of interfaces for the prosthetic sockets, and how this could all lead to people having a better chance and pursuing their dreams. And I have a hope that we're entering into a new era of technology to where disability does not define the user. We're looking at smart sensors, nanotechnology, haptic feedback, all being able to restore the sense of touch, the sense of purpose, and being able to affirm that their life really matters and that disability will not define you and won't keep you from anything you want to do. And I really believe that. And the kids we've seen are incredible, and they're already doing it. And as we zoom further into the future, we see a world where we could take your own stem cells. Some of our friends are working on this at our university and around the world. And it might be as easy as taking a swab of a boy in China who contacted us, a swab of his gums. He'd send that to the local UN regional office or a consulate there, a safe place that we're trying to create. From his own stem cells, his parents' measurements logged in on the internet, within 45 days, an automated drone flies him a new bionic arm, part organic, part traditional manufacturing, and a whole lot of hope. And so out of that, he'll be able to adapt and change everything. And we're going to get there. It's going to take a lot of work. And at our university, there's people already 3D printing the work for kidneys, pancreas, even the livers, which won't just help this, but also with drug testing. You can eliminate animal testing, and you'll know a lot more what these drugs are going to do. And so the technology and biomechanical and biomedical engineering is poised to really change everything. And we do know that there's a lot of families and a lot of children who wait on a transplant list, and too many of them don't get the option of a second chance of life. And I think as engineers, as storytellers, we're going to be able to capture that. Our generation is going to be the one that figures this out, and it's going to save so many lives, and it's going to instill a lot of hope. And that's our dream.